Hello, I'm Yegor Prikazuk, and this is the user guide of SCOPE, Soil Canopy Observation of Photochemistry and Energy Fluxes model. Today, we are going to talk about the lookup table mode of running the simulation 2, when and what for to use such an interesting, as you will see, simulation, and we will find limits of some variables of SCOPE. What I expect you have already done is you went to our GitHub and you downloaded the model with download zip. After that, you have unzipped the file, and now you can navigate to Scope Master, and you see these files. Also, of course, you have MATLAB, which would normally start with double click of Scope. See that the Scope is open, and we run it for the first time. The first run has 100 simulations, and hopefully you get the same message that the output is the same as in the verification dataset, which means we are good to go. What I also expect you to do is to find our documentation. The link is directly in the README. If we go to documentation, what we are going to reproduce is in options, rules of input reading, and this is rule number 2. It is illustrated in detail here, also with some text, and we are going to repeat this example. So, first thing we do, we go to our input options, and we change our 3 input files, file names, input data default, and set options, starting as always with set options. So, what we are going to do is we are going to make sure that the verification in line 8 is 0, and then the simulation is set to 2. This will enable a lookup table. Then we save the file and we close it. File names still remains optional for this tutorial. So the only thing we are going to change here is we are going to change the name, if you want to lookup table, lookup table run. And again, save it, close it. And input data default. To be able to run lookup table, we need at least 2 parameters to have several values, because otherwise it will be just independent runs, individual runs. For example, if we want chlorophyll to vary, to have 3 values, 20, 60, 40, and let's make something a bit more interesting than usual. So these are leaf parameters, but here in the bottom, starting from line 47, we have canopy parameters. And let's say that we want to see how reflectors of LAI, let's say 0 and 1 and 5 looks like. So what the lookup table option will do, it will take every value of sample parameters and make all possible combinations. So you will see in a minute what I mean. For now, we change LAI, we change chlorophyll, we save it, we close it. And of course, as always, we go one step backwards to the main folder, and we change set parameter file names, providing correct names. Set options is correct, file names is correct, input data Leti hypercube is not correct because we are using the input data default. Okay, so save it, close it, go to MATLAB, or if it's not yet open for you, you double click on Scope, and you run it. So we changed, we have 3 levels of chlorophyll, and we have 4 levels of LAI. That is why we have 12 simulations. Let's take a look at the output. Output, lookup table run. We are going to take a look first and parse an input short. So we are going this time to see just how the samples were varying. So first, Scope took LAI of 3 and all 3 levels of chlorophyll of 40, of 20, of 60. Then we change another value of LAI that I provided, and again we take all 3 levels of chlorophyll, and this was done as many times. If we look, for example, at again our file apparent reflectance, which shows spectrum, so reflectance per wavelength, and apparent because it includes fluorescence. So if I plot all of them in one graph, well, then we will see that, for example, this set of simulations that is very close to soil-like looking reflectors was done with LAI of 0. So let's see. Simulation in line 8 that indeed has LAI of 0. You can see how to plot this graph better and what other parameters mean in, for example, a previous video recording 2. So let's see now why will we want to do this kind of sampling. Well, that's very easy. We have two options. One case when we do lookup tables is when we want to train, well, in both cases, usually it's used now to train a machine learning algorithm, machine learning regression. It's either to speed up the computations. For example, if you work on an image per pixel, then do normal scope runs, they are too heavy to run. So what is then going to happen, it's called emulation. We are going to provide parameters as input, and apparent reflectance or any other output, fluxes output, spectral output, fluorescence output, is going to be a prediction. So we train a machine learning model saying, okay, when we use chlorophyll and LAI, or chlorophyll and carotenoid content in this case, of this, you provide us these reflectance. That's a forward mode, emulation. After training, it needs like maybe 5,000, maybe 50,000, depending on the machine learning algorithm you train. Typically here, Gaussian process regression is trained, and it will be much faster than scope at the end. But there is also possibility to flip these tables. So to say, okay, if this is the reflectance, what parameters would you match? So we're training on reflectance data, trying to get out from the spectra the matching combination of parameters. This task is called retrieval because we retrieve from remote sensing signal parameters, or it's an inverse run of the model. We'll maybe have a video on this in details, but there are already plenty of videos on YouTube, especially from the Valencia team, which developed ARTMO toolbox. So one more thing I would like to share with you is to keep in mind that the number of simulations grows multiplicatively. So if we have 7 leaf parameters and 2 canopy parameters, and we sample every parameter just 3 times, we're already going to end up in 19,000 simulations. That is why the lookup table approach, as it is in scope, with the direct linear sampling, may be good for teaching purposes, but for practical purposes, we use something more advanced, for example, latent hypercube, that we may cover in the following videos. Yet, there is an Easter egg kind of present for you. If you go to a scope in the main folder, and again in the code folder, SRC, source code, and lookup table, this is an advanced version of lookup table sampling that can generate lookup table input in the latent hypercube mode. And here, in this CSV file, you may find some hints on what are the expected ranges of, and also units and the meaning of some of the scope parameters. So once you create lookup table, it's worth noting which limits we have in model, which limits are realistic. So we learned lookup table sampling, simulation option 2, why to use it, and maybe hint why not to use it and to use more advanced samples to be covered in the next videos. Stay tuned.